Good afternoon to everyone. Today, we would like to finish the knapsack problem, and if possible, we'll move to the job sequencing with deadlines. One more problem, one more very important problem, that is greedy. So, greedy methods, another problem. Job sequencing with deadlines. Also, be there with us. So already we did something. So up to some extent we did here. That is, yeah. So that is, we have identified maximize profit. So we have to sort the given list of elements with the maximized profit values. So already these list of values are in maximized profit sorted order only. Even then, greedy is suggesting you that you have to sort again. Greedy is suggesting you have to sort again. Based on that, the values have been get sorted, and the values could be taken into consideration. So we did the problem for first kind of solution, that is maximize the profit of the knapsack instance. Now we'd like to take some second one. Second one is, as far as your so explanation point of view, second one is this one here. So minimize weights. Weights must be sort in non-descending order. Okay, non-descending order in the sense 1, 2, 3, 4, 5, 6, and so on and so forth. So you have to make them into non-descending order. Based on this one, we would like to take the instance one more time. I'd like to copy this particular instance to the next page. The page will be seen at this place. Yeah. So I have copied from over there to this place here, and let us solve this particular thing by using greedy method of knapsack here. I'd like to take this particular thing also right away from here to so here. Let me copy, because you people might have some kind of idea how algorithm will be. So look at this. So as far as this particular algorithm is concerned, so minimize weights. The problem will be, second thing will be minimize weights. So minimize weights is suggesting you. So you have to start the given instance based on the weights in non-descending order. Okay. So sort the entire instance based on the weights in non-descending order. So as far as the problem is concerned, so if you consider this particular problem, the problem is in descending order actually. The problem has given in descending order actually. So that we'd like to sort this particular list in non-descending order. So that for ascending order, and not exactly weights. You are also take care about the profits, associated profits also. So let us do the problem here. So first weight is smallest weight is 10, which is associated with W3. So therefore, on sorting, W3 will be the first value, and then followed by W2 will be the second value, and then followed by W1 will be the third value. So these are the three values which will be equal to 10, 15, and 18. These are the values here. Okay. And weight in. So these are the specific values which are available with us as far as the sorting is concerned. Non-descending order sorting is concerned. In a similar way, you have to take associated profits also as far as weights are concerned. So W3 associated profit will be P3, and W2 associated profit will be P2. So W1 associated profit will be P1. You have to arrange in such a way. Will be equal to, so P3 is 15, and so followed by 24. As it is, there is no change in second position, and the final one is 25. So here it is 25. Yes, sort operation is get shown. Then what shall we have to do? We have to initialize the value of x. So initially the value of x will be seen so something like this. It is an array which could be contains So because we have a three n equal to 3, since it is n equal to 3, we have to take into consideration of 3 so x values. This is the first problem, second problem, third problem. So here you please observe that x of 1 is associated with w1 and p1. You please observe that x of 1 is associated with w1 p1. X of 2 will be associated with p2 w2. X of 3 is associated with w3 and p3. Okay, based on that you have to consider the problem and have to solve the problem here. After that, I would like to check that this condition. So here, within this particular condition, what we did here, what we did here. So we did that. So x values will be assigned with zeros. So I'd like to make x values will be assigned with zeros here. So this is 0. Sorry, this is 0.0, and here it is 0.0, and here it is 0. Again 0. So assignment is over, and I'd like to take capital U equal to what is the capacity of knapsack? That is 20. 20 has been taken into consideration. Soon, so we have to start our work with Wi is greater than U or not. So what is the first element which is available with you? W3. So though I will be equal to 1, though you have I will be equal to 1 here, you need not to consider W1. Understand? The first element within the array or list will be W3. Whether W3 is what you call greater than U or not, that is the condition. So if so W3 is greater than capital U or not. So it could be gives you what is the value of W3? 10. 10 is greater than 20, which is false. Since it is false, you have to take these two initiations. That is x of I equal to x of I in the sense x of 3. That is what you need to consider here. X of 3 equal to 1. So it has been changed to 1.0. And then followed by U equal to U minus, so Wi. So U will be updated with U equal to U minus W of I, that is W of 3, will be equal to, so 20 minus 10, that will be, you have still 10 more units are there. So 10 more units of space is there in the knapsack. Then I will be gets incremented, that is I will be goes to next weight, that weight will be this one, so W2. So same query or same conditions will be gets followed here. So this is the first point, and second point will be, so if W2 is greater than capital U or not, let us check out this one here. So what is the value of W2? That is 15. So 15 is greater than 10. Yes, it is true. Yes, it is true. So therefore, we need not continue, and a break will be taken into consideration. So we need not continue here. Then what exactly we are supposed to do? If I is less than n, I equal to actually 2. So 2 items have been placed, n will be equal to 3. So third item is left over. So that what we are supposed to do? X of 2 will be equal to. So here the condition will be, so x of 2 will be equal to, so let us consider x of 2 will be equal to, so whatever the value which is left over with the knapsack, that is U divided by W of 2. W of, so the value could be considered as something like this. So it could be taken 10 divided by 15. 10 divided by 15 is approximately given. So let me take a calci, but you are not allowed calci to examination hall. So you have to do it here. You have to do it at your own. 10 divided by 15 will be equal to 0.6. Look at this. This is 0.6. So therefore, the value is 0.6. Therefore, This one will be 0.6 here. 0.6. So how you have to fill the bag here in the sense, the third weight will be completely placed into the bag, and the second weight will be placed up to 60%. The remaining 40% will be left over with the same place. And first item, otherwise first dust cannot be considered, and it is left over with the same place within the cave. Okay, so this is the consideration. And how then? What is the profit which is being earned here is therefore sigma. So total profit will be sigma. So 1 less than or equal to I is less than or equal to n. So what we are supposed to do here, pi into so xi. So that could be taken as p1 so x1 plus so p2 x2. So continuously you need to write like this, p3 x3, p3 x3. So p1 into x1 will be equal to, what is the value of x1 value? 0. X2 value is 0.6, and x3 value is 1. Then what is the profit of the first item? So first item is 25. This is first item, and this is second item, and this is the third item. First item is 25. So let us consider so 0 into 25. So plus 0.6 into so 24 plus so 1 into 50. So if you calculate everything here, it could be 0 plus so 25 into 0.6. 24 into 0.6 will be 14.4. So it is 14.4 plus 15. So on accumulation, it would be gives you 29.4. This is the total profit you may be get if you follow. So if you follow the second one, minimize weights. We take this one. So weights will be take first minimum weight and place it to the bag, and the second place into the bag, third into place into the bag, and so on and so forth, up to the satisfaction of the objective function, that is the weight must be placed into the bag until less than or equal to m. Okay, so here as far as weights are concerned, so capacity of bag is just 20 units, and weights are 10, 15, and 18. So therefore, we'd like to place 10, and 60% of second item is going to be placed into the bag, and the third item, that is first item, is not supposed to be considered anymore. So therefore, we got the answer as 29.4. You can see maximize profit. If you take maximize profit, 28.12 has been. So this is the answer. Whereas so minimize weights, so a slight increment is there in the profit. Slight increment. Now the third one. Third one is like to consider the third one as what is the third one as far as your thing? Maximize the profit for weight ratio. Maximize profit for weight ratio. This is the third one. So third item will be seems like this. Let me copy somewhere else. Okay. The third point will be so maximize profit for weight ratio. So this is the specification here. This is the specification. So try to copy the same problem, because we may not remember this particular problem very well. So that let me copy this one and paste here, so that it is very easy to remember and very easy to identify. So this is the third kind of so thing which is there with me, so with us, not with me, with us, and then solve this particular problem. So if you solve this particular problem, so what are the arrangements we have to make here? Let us go ahead and discuss this one also here. Okay. So here, first of all, we need to identify something like this. First, we need to consider P1 by W1 for profit for weight ratio here. So P1 divided by W1, comma P2 divided by so W2, comma so P3 divided by W3. We need to identify these values, profit to weight ratio values. So that could be P1. What is the value of P1? 25. 25 divided by 18. So first one, followed by 24 divided by 15, and then followed by 15 divided by some 10. We know 15 divided by 10 equal to 1.5. That is well known to us. So based on this one, what is the specific values you got here? And let me calculate one more time. So 25 divided by 18 will be 1.3. So this is first value is 1.3, comma. So 24 by 15, what is the value? 24 divided by 15 will be 1.6. Next value is 1.6, and of course this is 1.5. We take into consideration. So as far as the problem is concerned, it is maximized profit weight ratio. This is the first element which is going to process. So this is the second element which is going to process, and this is the third element which is going to be processed. Therefore, we have to adjust the profits and weights as far as the order which has been get with respect to profit and weight ratio. So therefore, one moment, please. Sorry, please not. The length is not supposed to be fit with us. So that let me increase the length one more time. I thought that this could be satisfied. Okay. So as far as this particular thing, so you have to sort the given instance with the profit weight ratio in maximized mode. That is descending order mode. So therefore, P2. So P2 will be the first element which is going to process. Then P3. So then followed by P1. And followed by P1. Look at this. So P2 is having highest profit weight ratio. This is the maximum value. This is second maximum value. This is third maximum value. So therefore, the values will be seen in such a way that what are the values? What is the P2 value? 24. Then followed by 15. Followed by 25. These are the values. And then similarly 25. Similarly, the weights also must adjust here. W2, so W3 associated weights must also be W1. So if you are supposed to take into consideration that what is the value of W2? 15. So W2 has 15, and this is 10, and this is 18. Okay, that is 18 here. So we have to adjust this adjustment. After this adjustment, and we have to follow the same procedure, whatever the procedure we did in the previous instance and the last instance. So what we are supposed to do? So we have to initialize a x value for this particular problem also. So totally 3 elements are there. So therefore, element 1, element 2, something like this. This is x, 1, 2, 3. These are associated with the actual values. Initially, everything will be taken as 0, and so here also 0. This is also 0. This is 0, 0. Okay. Now I like to take first condition is if what is the condition? So W of I, weight of so-called I is greater than capital U. Okay, one more thing has been left over here. That is capital U equal to capacity of knapsack. That is 20 units. Okay, this condition. If you take this particular condition, what is the weight of first element which is been there? Weight of first element is this much. 15 is greater than. So 15 is greater than 20. So which gives you parts. Therefore, x value, x of 2 will be considered as 1.0 here, and then so u will be what is that? U will be reduced. U will be reduced to u equal to u minus w of 2. So that will be equal to 20 minus 15. So 5 more units are left over with the knapsack. Okay, 5 more units are left over with the knapsack. Then one more time. So if So next element which is been there within the list. So this element has been processed. Next element is this one, that is W3. So W3 is greater than U or not. Let us check about this one here. So here it is. So what is the value of W3? 10 is greater than 5. Yes, it is true. Since it is true, we would like to take the value. X3 value will be calculated. X3, so X of 3 will be calculated. So what is the leftover with the knapsack? That is 5 units divided by 10. 5 units divided by 10 in the sense 0 0.5. 0 0.5. So here it is 0 0.5. And the first element is not supposed to be considered anymore because knapsack is already filled and there is no space to be filled. Now, so the total profit will be, this is the way to get the total profit. So sigma I equal to 1 to n, so pi into xi. So that could be already formalized there with you. So that directly I would like to write what is the first value of profit here. First value of profit will be 25. So that is P1 x1 plus P2 x2 plus P3 x3. Okay. Now, what is the P1 value? P1 value is 25 into 0. 25 into 0 plus P2 value is, so 24 into, so what is the value of P2? That is x value of x2 equal to 1 plus, so next one is 15. 15 into, so 0 0.5. 0 0.5. That will be 0 plus, so 24 plus, so 15 divided by 2, that is 0 0.5 in the sense exactly half, that is 7.5. 7.5. Therefore, you got so approximately 31.5 units of profit is going to be acquired with the third one. So therefore, the problem will be maximize the profit. Let me draw some more. Then it would be very easy to explain by me. So look into this particular thing. So here, so we got something. This is the conclusion actually. So maximize profits. I've got something here. Let me move towards back and check it out. So 28.12 units of profit has been acquired. So this is the first answer. And the second one is minimize weights. So if you take minimize weights, what is the profit you got if you place the minimize weights into I think here that is 29.4 units of profit has been accepted. And the third one is maximize profit for weight ratio. If you take this particular thing, so what is the output here? The output will be so output will be 31.5 units. So which is better here? So the third one, profit for weight ratio is better one. So therefore, that is the answer for this particular thing here. So therefore, you need to understand that the profit for weight ratio has given maximize the profit. So therefore, that is the answer. So the final answer is 31.5 units of this particular problem. So this is the problem here. I'd like to forward this particular problem to you. So entire problem to you. Then you please go through this one, and you could get some kind of idea. And I would also write the same on the paper and take the photograph, and I'll forward the same thing to you through Google Classrooms. Thereby, also you please go through. And you are expected to perform this particular problem and submit to Google Forms by tomorrow. Let me open where it is. Card CSE and the previous question papers. Let me take so here. Please take this particular question paper and please note down this particular question and submit the same by tomorrow. I'll give you the thing here. Uh, Using a dynamic problem. So dynamic programming cannot be solved using greedy. Yes, this one. Yeah, greedy method. Use greedy algorithm for sequencing unit time. Job scheduling. No. Sorry. It is job scheduling actually. It is not. Okay, one more. It is not there. No problem is available. Yes, we got it. So for instance, knapsack instance and greedy method, number of elements will be so 7. Number of objects will be 7. So capacity is 50 minutes and associated profits will be this and associated weights are these. You please solve this one. The question has given to you in your R16. So 2019 May. In 2019 May, you got this particular question. Okay. So you please observe at least in one question, knapsack will be available in twice in the question paper. So here it is exact problem, and here discuss about 0/1 knapsack with the branch and bound. Okay, knapsack must be there in our question paper. So if you do understand what exactly the knapsack will be in the greedy method, it's very easy to understand regarding to dynamic programming and branch and bound also. You have to perform this particular problem and submit me by tomorrow in the evening. Okay, so that's it. So I have only 10 minutes of time with me, so it is not possible to complete job sequence with deadlines. So tomorrow we shall see what is that complete problem, and we'll finish off job sequencing with deadlines by tomorrow. Okay. So already I have prepared something regarding to job sequencing and deadlines, but it could not be because explanation will be very huge before going to start the problem. So that is why it could not be finished off within 10 minutes of time. Okay. However, today the class will be only 30 minutes, exactly 28 or 29 minutes. Tomorrow we shall take the class. Okay. Thank you, and don't go away because I'm going to take attendance of you. So just wait for a few minutes, then it will be very easy to take attendance of you. I've taken again. Yeah, thank you, and I'll send this material also to you by today in the evening. Already I have sent some material to you. I don't